Hey physiology class, what's pumping, yo? Students, you should be able to identify and locate the major parts of the heart and know the function of each of those parts. You're also going to be able to identify the major blood vessels going into and out of the heart. And you should also be able to trace the pathway that blood flows as it moves through the pulmonary circuit. Watch this video for a quick overview.
The circulatory system, consisting of the heart, arteries, capillaries, and veins, is the pumping mechanism that transports blood throughout the body. In the heart, the left ventricle contracts, pushing red blood cells into the aorta, the body's largest artery. From here, blood moves through a series of increasingly smaller arteries until it reaches a capillary, the junction between arteries and veins. Here, oxygen molecules detach from the red blood cells and slip across the capillary wall into body tissue. Now deoxygenated, blood begins its return to the heart. It passes through increasingly larger veins to eventually reach the right atrium. It enters the right ventricle, which pumps it through the pulmonary arteries into the lungs to pick up more oxygen. Oxygenated, blood re-enters the left atrium, moves into the left ventricle, and the blood's journey begins again.
Your cardiovascular system consists of your heart and your blood vessels. Your heart is roughly the size of your fist. The heart is posterior to the sternum or behind the sternum, so we have a nice bony shield protecting it. It also gets some protection from the ribs. It's between or medial to the lungs. It sits in front of your vertebral column, and it's sitting on top of your diaphragm muscle right here. You can see the heart is also a little bit more to the left side than the right side. The heart sits in its own little cavity up here called the pericardial cavity, and it's got its own little protective sac around it, which we call the pericardium. So we've got a slice through the wall of the heart here, and the wall of the heart is made of 3 layers of cardium tissue. So the innermost layer right here, the endocardium, is a connective tissue layer. And then we have the myocardium, which is actual cardiac muscle tissue, which is responsible for the contractions or the beating of the heart. And then sitting right on the outside of that heart muscle is the epicardium, which is also called the visceral pericardium. So the heart muscle tissue is sandwiched between 2 layers of connective tissue. And then we can also see in our picture here that outermost tough layer that we saw in that last slide. This is that parietal pericardium, the sac that the heart's sitting in. So we've got a nice section or cross section through the heart, and you can see the chambers, the 4 chambers, some of the valves. You can see major blood vessels leading to and from it. And everything that's labeled here, you're going to be responsible for being able to label yourself on a diagram. So let me point out the chambers really quickly. Here is the right atrium, the right ventricle, the left atrium, and the left ventricle. So there's the 4 chambers of the heart. So the right atrium is receiving the deoxygenated blood or the used up blood from the body. So up here we have our superior vena cava, which is draining the blood from the head, neck, shoulders. Down here is our inferior vena cava, where the blood from the lower part of the body up through your abdomen up towards the heart, all of that deoxygenated blood is returning back to the heart. And then the blood leaves from the right atrium and goes really quickly down into the right ventricle here. So blood leaves the right ventricle and goes out this pulmonary artery, heads to the left lung, heads to the right lung this direction, and then that blood is reoxygenated. The lung tissue supplies it with oxygen, and then the blood returns over here via the pulmonary veins into the left atrium, and then a real quick trip down here to the left ventricle. Let's go through this one more time. So blood, deoxygenated blood, is going to enter through the pulmonary veins. Veins always carry blood back to the heart. So it's coming back to this right atrium here. It's going to go through this tricuspid valve into the right ventricle. It's going to go up through the pulmonary valve, through the pulmonary trunk, and out the pulmonary left artery, pulmonary right artery. It's going to head to the lungs. That blood will be re-oxygenated, and then it will return through the left pulmonary veins. So veins again bring blood back to the heart. So it comes to the left atrium, goes through the mitral valve into the left ventricle, and then it's going to leave out the biggest blood vessel in our body, the aorta. And the aorta goes up to the head, and it loops around and comes all the way down here and supplies the lower part of the body with blood in the abdominal aorta. Veins always carry blood to the heart. Arteries always carry blood away from the heart. In most cases, veins have deoxygenated blood, except in the case of our pulmonary veins right here. So these veins are the only veins in the body that are carrying oxygen-rich blood because they're carrying blood that just came from the lungs and was re-oxygenated there. Arteries will always carry the good oxygen-rich blood, except in this case right here. This artery, the pulmonary artery, coming off the pulmonary trunk here and the pulmonary arteries, are the only arteries that are carrying bad deoxygenated blood.
How the blood flows in the heart. Beating on average 70 times per minute, each day the heart beats about 100,000 times. In the course of a 70-year lifetime, it will beat more than 2.5 billion times without ever pausing to rest. The cycle of blood flow is as follows. The right atrium receives blood from the great veins, the superior and inferior vena cava. Blood passes from the right atrium through the tricuspid valve to the right ventricle. From the right ventricle, blood is pumped through the pulmonary valve and pulmonary arteries to the lungs. In the lungs, carbon dioxide is removed from the blood and oxygen is picked up. Through the pulmonary veins, oxygenated blood returns to the left atrium. From the left atrium, blood passes through the mitral valve to the left ventricle. As the left ventricle contracts, the pressure closes the mitral valve. The aortic valve opens, allowing blood to leave the heart via the main blood vessel called the aorta. When this cycle of pumping is complete, the aortic valve closes to prevent blood from dropping back into the heart. The heart is two separate pumps that work together. Oxygenated and nutrient-rich blood is pumped around the body. Deoxygenated blood, which contains waste products, is returned to the lungs to allow the entire cycle to begin again.
The job of the heart valves is to regulate the direction that the blood flows. We need it to go one direction only. For example, we want it to go from the left atrium to the left ventricle and out the aorta, and that's the only direction it can go. So we have valves that do that regulation. So we have AV valves, or atrioventricular valves, between the atrium and the ventricle. On the right side we have the tricuspid, on the left side we have the bicuspid. So the tricuspid has 3 flaps, the bicuspid has 2 flaps. And then leading out the 2 major vessels leaving the heart, we also have valves. So the pulmonary valve is in the pulmonary trunk, and the aortic valve is in the aorta, and these are both semilunar valves. They look like half moon, semi-lunar, half moon. If the valves aren't working properly and they allow some of the blood to backflow, just little leaks, we call that a murmur. And when the doctor's listening to your heart, he can sort of hear, instead of a nice crisp lub dub, he'll hear a sounds like a liquid is swirling around in there a little bit. On the right here we see the tricuspid valve. It's between the right atrium and the right ventricle, and it works a lot like a parachute. So the flaps of the cusps catch the blood as the blood is being pushed back towards the right atrium from the right ventricle. So they fill with blood, and that's actually what closes the valve. And then we have these little chordae tendineae here that hold on to the flaps as they fill with blood, and they don't let them prolapse into the right atrium. On this side, we've got a cross section through the heart, and we can see all 4 of the valves. So this is our tricuspid, this is our bicuspid. You can see it has fewer flaps. And then here's our semilunar valves over here. And as you can see, that looks like a half moon. So we've actually got 3 kind of half moon shapes here and 3 half moon shapes here. So this is the same view as the last picture of the heart. We have our tricuspid, our bicuspid, which is also called the mitral valve. This is our aortic valve at the beginning of the aorta, and our pulmonary valve at the beginning of the pulmonary trunk. So here we can see the whole pulmonary circuit. Here's the deoxygenated blood coming in from the head and the rest of the body, entering our right atrium. It's going to go to our right ventricle. It's going to go out the pulmonary valve through the pulmonary trunk, head over into our right and left pulmonary arteries. It's going to return into the left and right pulmonary veins into the left atrium, go to the left ventricle. It's going to go out the aortic valve, and now it's oxygen-rich blood, and we're going to have a whole lot of happy tissue cells relieving a new, fresh supply of oxygen. In the lung tissue, gas exchange is going to occur in these alveolar capillaries, so the poor deoxygenated blood rich in CO2 is going to be exhaled out, and we inhale air full of oxygen, which is going to replace it in these capillaries. And we'll learn more about that in the respiratory system chapter. I just wanted to reference this little chart that's in your textbook. It's a nice little study tool, so you can start at the top, put your hand or a piece of paper over all of the different labels, and see if you can trace the path of blood through the heart, because you're going to have to be able to do that on the test. Thanks for watching. Now try memorizing some of those parts.